Hi everyone, this will be a video walkthrough of number 6 from this homework set. So in this problem, you have water flowing at the rate of 50 cubic meters per minute from a shallow concrete conical reservoir, vertex down, which is just a reservoir shaped like a cone. The base radius is 45 and the height is 6 meters. So we'll go ahead and show you a picture of this. So just a conical reservoir of water, so a holding place of water. This base radius here is 45 meters, and this height, the height from the center of the base all the way to the vertex, is 6 meters. And we are also given that the water is flowing out of this reservoir, so through the bottom, at a rate of 50 cubic meters per minute, which is the rate that the volume is changing. So that 50 is your dV dt, your volume, the rate the volume is changing. And since the volume is becoming less, water is leaving, that'll be a negative 50 meters cubed per minute. Cubic, yeah. So let's see, what else do we know? We know that we are looking for how fast the water level is falling when the water is 5 meters deep. So we're looking at a height 5 meters. And we are looking for how fast the water level is falling, which is this height. So we're looking for dH dt. And then the second question is how fast is the radius of the water surface changing, which is your dr dt, the rate of the radius and the rate of the height. So that's these two. We are looking for dH dt and dr dt. So with these cone problems, you are always going to use similar triangles and proportions. So for example, we'll compare the radii. So this radius is 45, and we'll compare it to whatever this radius is here, we don't know. So here we'll draw this arrow. So 45 is this original radius, this base radius. That's proportional to this smaller radius, whatever it is, when the height is 5. So that's compared to a height of 6 over a height of 5. So we're just comparing similar triangles here and setting up our proportion. And when the height is 5, we can use this proportion to find the radius. So we'll solve for the radius. This ends up being 45 times 5, so we're just like cross multiplying here. So 45 times 5 equals r times 6. So then 45 times 5 is 225 divided by 6 here. So we find that the radius, when the height is 5, the radius is 37.5 meters. Don't need that. All right, so we got the height, we've got a radius, and we're looking for two different things, dH dt and dr dt. So we're going to need two different equations, and we'll walk through this one first. So we're going to find an equation to compare these two rates, and then we'll use the volume formula to just solve for one of the rates. Okay, so here's our triangle that we're working with. Our set of similar triangles really here. All right, so we got this base radius of 45, this r, which we now know is 37.5, this height, which we're looking for when the height is 5, compared to the total height of it, which is unchanging, which is 6. So we can use this proportion here, just like we set up before. So this 45 compares to whatever radius is always equal to 6 over the height at that time. It's a proportion because they're similar triangles. And then cross multiply, we get 45h equals 6r. And solving for h means we get 6r over 45 is equal to h. Now we can derive both sides to find the relationship between dH dt and dr dt. So the derivative of this left-hand side, the derivative of h, is going to be 1 times dH dt, which you can just write as dH dt. Oh, sorry, first we can simplify this as well. And then we get this derivative is dH dt. Okay, so the simplifying, you just divided by 3. So 6 divided by 3 is 2. 45 divided by 3 is 15. You still got that r. Okay, and now we'll take the derivative of 2/15 times r, which will be the derivative of 2/15 r is 2/15 times the derivative of r prime, or dr dt. And that is the relationship between the rates that we're looking for. So we're going to hang on to that. We're going to come back to it. Now, let's solve for one of these rates using the volume formula. So volume of a cone is 1/3 pi r squared times the height. Now, we have two variables here. I want to just make there be, so we have the radius and the height. I want there to just be one variable so that we can then solve for that rate once we derive. So you can choose to replace r with what the radius, okay, coming from this equation here, 45h equals 6r. You could solve for r, but we already solved for h, so we're going to use that. So we found that h is equal to 2r over 15, so we're going to go ahead and replace h with 2r over 15. So then we'll have this just in terms of one variable, because we know what the derivative of v is, so we'll have everything in terms of r. So once we derive it, this will allow us to solve for dr dt, and then we'll come back down here, plug in what we get for dr dt, and then we'll be able to find dh dt. Okay, so simplifying, multiply this 2/15 times this 1/3 gets us 2 over 45 pi r cubed is equal to v. Now is when we derive both sides, so the derivative of v, the volume, is dv dt, and that is equal to, okay, so power rule says that, okay, hang on, before I say that, this 2 over 45 pi is a constant, so that will just, we can pull that out of the derivative essentially, and then this r cubed, we'll use the power rule, so pull that 3 down, and then subtract 1 from the exponent, so you'll end up with an r squared. So 3 times 2 over 45 ends up being 2 over 15 pi r squared is what you'll end up with. And then implicit differentiation tells us that we also multiply by the derivative of r, which is dr dt, which is what we are looking for. And then we'll use that dr dt to solve for dh dt. Okay, so let me write that down. Okay, now we know what dv dt is. We found that that was given to us. It's negative 50 cubic meters per minute. We know what this radius is because we found that over here. When the height is 5, the radius is 37.5 meters. So we can go ahead and plug those in, and then that will allow us to solve for dr dt, because then we just have one unknown. So when you do the math here, use your calculator, square 37.5, multiply by 2/15, and then take negative 50 divided by all that to just get dr dt by itself. You end up with dr dt is equal to negative 0.085 meters per minute, which, if you change that to centimeters per minute, which I believe was asked from you in the homework, you just move this decimal point over 2, so it'll be 8.5 centimeters per minute, excuse me. Then, to find dh dt, you plug in this dr dt into this equation right here. dh dt equals 2 over 15 times dr dt, which is kind of given by this little rough sketch right here. So an exact answer is going to be, so this dr dt is equal to negative 50 divided by 2/15 pi times 37.5 squared, which is this number exactly, and then multiplying by 2/15 to find dh dt, and you get this answer, which, remember, this is meters per minute, so to change that to centimeters per minute, go ahead and multiply by 100. So this will be 1.13 centimeters per minute. And that's the rate that the height of the water is changing. And then drdt is the rate that the radius is changing. Hope this helps. Let me know what other questions